Hi everyone, today we're looking at 3.7, which is absolute value equations and inequalities. When you are looking at absolute value equations, there are a couple of things that you have to remember. So let's look at some of these true and false and see what you remember. Take a second, try to answer them, true or false, and then we'll go over the answers. Keep in mind that what goes in an absolute value can be either negative or positive. It's just that you know when the answer comes out of the absolute value, it will be positive, because absolute value is the distance of something, of a number from 0. Distance can never be negative. Distance is always positive. If I talk about how far it is from my house to school, and then from school back to my house, it's not then going to be a negative distance just because now I'm going the other way. Distance is always going to be positive. So let's see, number 1. To indicate the absolute value of negative 8, you write absolute value bars negative 8. This is true. The absolute value of negative 8 is negative 8, since negative 8 is 8 units to the left of 0 on the number line. This is false, because remember, absolute value is the distance of negative 8 to 0, and the distance of negative 8 to 0 is 8 spaces. Doesn't matter where it is on the number line, it's still 8 spaces away from 0. So it would be a positive 8, the absolute value. Number 3, the absolute value of negative 8 is positive 8, since negative 8 is 8 units away from 0 on the number line. This is true. Number 4, according to the definition of absolute value, if the absolute value of r equals 3, then r equals 3 or r equals negative 3. This is also true. What's in the bars doesn't matter as long as what comes out of the bars is positive. Okay, so what are the solutions of absolute value of x plus 2 equals 9? In order to solve an absolute value equation, you have to first get the absolute value alone. So in order for me to get the absolute value alone, I have to get rid of that 2. So I'm going to subtract 2. Let's get our pen going. I'm going to subtract 2 from both sides, and I get absolute value of x equals 7. Since we know that every absolute value has the possibility of having a negative or a positive inside, because whatever comes out is positive, then we know that we have to take that into account when we are solving equations. So the first thing is, once the absolute value is alone, it must be equal to a positive. It cannot be equal to a negative, because if it's equal to a negative, it's a no solution. Nothing is going to come out of the absolute value and be negative. So this one is equal to a positive, so we continue our problem, and we're going to make 2 equations. One that is exactly the same, and one that is equal to a negative. So now I know that my x can be positive 7 or negative 7. Okay, so let's look at a little bit of a more complicated problem. So on this one, again, we have to get the absolute value alone. So I'm going to first move over the 12, because you always do the addition subtraction before you do any kind of division. So I end up with 3, absolute value of 2z plus 9 equals negative 2. Then I would divide by 3. So now I have absolute value of 2z plus 9 equal to negative 2/3. My absolute value is alone, and at this point I need to make sure that it's equal to a positive, and it's not. If you notice here, it's equal to a negative 2/3. So that means that this is a no solution, because you will not ever have an absolute value that is negative. Try doing the problem underneath. Take a second and see if you can do it yourself. So this one is already by itself the absolute value, so I don't have to do anything to get the absolute value alone. It's already alone. So I can already split into my 2 equations. Here is going to be one of them, exactly the same as it is. Here is the other one, now equal to a negative, and I solve each one. So I get r equals 13 and r equals 3. And if you plug it back in, you see that it works. 13 minus 8 is 5, and the absolute value of 5 is 5. And 3 minus 8 is negative 5, and the absolute value of negative 5 is also positive 5. Try doing this problem. check to make sure that you got the right answers. We divided first, got the absolute value alone, and then split into our two equations. We have our two answers. Just check really quick. 7 plus 7 is 14. Absolute value of 14 is 14. Negative 21 plus 7 is negative 14. And the absolute value of negative 14 is 14. So you know you did it correctly. With an absolute value inequality, there are a few small differences. First thing you have to do is, just like in an absolute value equation, get the absolute value by itself. So in this example, n minus 1 is greater than 2. The absolute value is already by itself. I don't have to do anything. And once the absolute value is alone, I want to look at the sign. If it's a greater than sign, it's an or, great or. If it's a less than sign, it's an and. In this case, it is a greater than sign, which means it's an or. And I want to make sure that it's equal to a positive. Because if it's equal to a negative, then I have a special case. So let's write that down. Okay, so we wrote this down. When you have a greater than sign equal to a negative, it's a special case, which is all real numbers. So an or greater than a negative is all real numbers, which means you shade the whole line. You don't even have to work out the problem. You already know it's going to be in all real numbers. So we look at this one here. It is not equal to a negative, which means it is not in all real numbers. So I'm going to go ahead and solve it. And the way that I solve it, if it's not a special case, is get the absolute value alone. Once the absolute value is alone, make my two equations. So I'm going to have one that is exactly the same. And then I'm going to have one that is n minus 1 is less than, so you flip the sign and make the number negative. Then I solve. So I'm going to add one here, add one here. So n is greater than 3. Or, because I know it's an or, I'm going to add one here, n is less than negative 1. So n is greater than 3 or n is less than negative 1. I graph this. So it is greater than 3, which is a parentheses, and greater goes this way. Less than negative 1, which is a parentheses, and it goes this way. And in interval notation, I would say negative infinity, comma, negative 1, or 3, comma, infinity. Take a second and try this problem down here. See if you can do it. Make sure you get the absolute value alone first. Take a look at your answer. You first move the 1 over to get the absolute value alone. Once you do, you have a greater than 1. So it's an or. It's not a special case because this is a positive. Make our two equations. One is exactly the same. And the other one, you flip the sign and make the number negative. Solve them both. So you get x is greater than 4 or x is less than 3. Graph it. And then do your intervals. So when I graph it, I see x is less than 3. It's a parentheses. It's going this way, which means in my interval it's going to be negative infinity, comma 3. When I graph the 4, I put my parentheses. It goes this way because it's greater than 4. And it is going to be in parentheses 4, comma infinity. Let's look at what happens when you have an and. So just like an or, if you had a greater than a negative, you had a special case. Same thing with an and. If you have a less than a negative, you also have a special case. If it's less than a negative, it's going to be a no solution, because that means that they're going to go in opposite directions, and you can't have an and going in opposite directions since the answer should be in between two numbers. So let's write that down so we don't forget. So here we have it written down now so that you can use that as a guideline later. When you have a less than sign and then a negative, it's a special case, which is no solution. So an and that is less than a negative, no solution. And that's also obviously once you have your absolute value alone. So in this case, we do the same thing. Absolute value is already alone. It's not equal to a negative, so we do two different equations, one that is exactly the same, and one where we flip the sign and change it to a negative, and solve it. Okay, we graph. So an and should go towards each other, and since this is not a special case, they will go towards each other. You have n is less than 3, parentheses, less than is this way, and n is greater than -1, parentheses, and it goes this way. So they are shaded in between. And our interval, since it's an and, there are no infinities, would just be -1, comma 3. Go ahead and try the next problem. Take a look at the answer. Very important that you remember when you divide by a negative with an inequality, you must flip the sign. So don't forget to flip the sign when you divide by a negative. So you had x is less than or equal to 2, and x is greater than or equal to -2. Both are brackets because now they're equal to. And here is your interval. So let's take a look at these special cases. If you look at the first one, we have to again get the absolute value alone. So I'm going to subtract 5. So that gives me 3x plus 1 is less than -4. So I have a less than and a negative number here, which means this is a special case. And since it's a less than, it's an and, which tells me that it's going to be a no solution, because that's a special case for and. So therefore my graph stays empty and I have no interval. Now look over here. I would divide by -4. Remember, when you divide by a negative, you have to always flip the sign. So now it is, I don't know why these lines keep popping up. So now it is an or, greater, and it's equal to a negative. So greater to a negative is, again, a special case. And that means it's going to be in all real numbers, because special cases for or is always all real numbers. So for this one, the graph is completely filled out because you're saying every number is a solution, and your interval is -infinity to +infinity. So all real numbers, everything on the number line. Go ahead and try doing this one down here. I'm going to give you take a few minutes, pause the video, and then look at the answer. Okay, here's the answer. When you divide by a negative, remember the sign flips, so it becomes a greater than. Great or equal to a negative is in all real numbers, so you shade the whole 9, and your interval is -infinity to +infinity.